In this lesson, we will learn about the frame forwarding process in Cisco switch. We'll learn about the following processes that a switch uses to forward Ethernet frames: learning MAC address, flooding unknown unicast frame, forwarding known unicast frame, and flooding broadcast frame. Finally, we'll sum up our lesson with the keynotes. Before going into detail of each process, let's talk about the network setup for this lesson. Here are the network components. As you can see, we have 4 PCs and 2 switches. Each PC is configured with an IP address associated with a MAC address. All switch ports belong to the same default VLAN, VLAN 1. At the initial setup, the MAC address tables of both switches are empty. Let's look into the scenario when PC1 sends data to PC3. To send data to PC3, PC1 must forward its frame to switch 1 via the port F01. Upon receiving the frame, switch 1 extracts the content to get the source MAC address. It finds that the MAC address is not in its MAC address table, so it creates an entry in the MAC address table. The entry includes the MAC address of PC1, the port F01 where the frame coming from, and VLAN 1 where the port F01 is located. Next, switch 1 extracts the destination MAC address and searches for the MAC address in its MAC address table, but not found. Therefore, it must flood the frame out to all active interfaces except the interface where the frame comes from. In this case, it forwards the frame out to the following ports: port F02 toward PC2. PC2 reads the destination MAC address of the frame and knows the frame is not for itself, so it drops the frame. And then it also forwards the frame out to the port G01 toward port G02 on switch 2. Upon receiving the frame from switch 1, switch 2 extracts the content of the frame and it finds that the source MAC address does not exist, so it adds a new entry containing the MAC address of PC1 and the port G02 where the frame comes from and the VLAN 1. It also finds that the destination MAC address is not found in its MAC address table, so it floods the frame out to the following active ports: the port F04 toward PC4, and PC4 reads the destination MAC address of the frame and it finds that the frame is not for itself, so it drops the frame. And it also forwards the frame out to port F03 toward PC3. And PC3 reads the destination MAC address of the frame and it knows that the frame is for itself, so it gets the data. Let's look into the scenario when PC3 replies to PC1. Upon receiving the frame from PC1, PC3 replies back to PC1 via switch to port F03. Switch 2 extracts the content of the frame and learns the source MAC address of PC3 and adds it into the MAC address table. Switch 2 found the destination MAC address of PC1 in its MAC address table, so it forwards the frame out to interface G02. Upon receiving the frame from switch 2, switch 1 extracts the content of the frame. It learns the source MAC address of PC3 and adds it into the MAC address table. Switch 1 also finds the destination MAC address of PC1 in its MAC address table, so it forwards the frame out of the interface F01. PC1 reads the destination MAC address of the frame and knows the frame is for itself, so it gets the data. Let's look into the scenario when PC4 sends data to PC2. Now it is your turn to figure out the same process by watching the activities in the diagram. Next, it is your turn to figure out how PC2 replies back to PC4. Let's look into a special scenario when PC1 sends a broadcast frame. In this special scenario, you need to figure out the process by watching the activities in the diagram. All the source MAC addresses had been learned, but they're still being checked. I just skipped that step to make it simple. The broadcast MAC address is all Fs. It tells the switch to flood the frame out to all the active ports except the port where the frame comes from. Let's do it. Let's read the keynotes by yourself to finish this lesson.